function. So here we have a polynomial function, specifically a quintic, where the information is given in a graphic form. So let's look at the features, some of the features of this function, such as the zeros. So the zeros are the x-intercepts, or the points, the x values where the function, the purple graph here, crosses the x-axis over here and over here. So in our case, the x-intercepts is going to be x is equals to 0 and x is equals to 2. The next thing we need to know is the degree, the leading degree, the highest degree of this polynomial function. And we know that in this case it is equal to 5 because it's been given x. So the degree is going to be equals to 5. And if you just look at the function overall, the end behaviors, let's just say I didn't give you the degree. We can look at the end behaviors of this function over here and over here, and we know that the end behaviors are opposite. And for polynomial functions, it is the odd degree functions that have opposite behaviors. So this function could be to the degree of 5 or 7, and you should ask yourself, why can this function not be a degree of 3? But we can talk about that in the next example. So let's look at the multiplicities. So multiplicities are at the 0. So let's have a look at over here and over here. We can tell that there is a turning point at x equals to 0. So over here, we know that there is some sort of even degree multiplicity. Over here, in this area here, we have what we mentioned before, an inflection point. So over here at x equals 2, there is an inflection point, or a cubic-like feature, which indicates that the multiplicity is going to be odd. So let's start off with the possible factored form of this quintic function by starting off with the following. Y is equals to, we're going to have two brackets because we have two zeros or two possible factors. In this case, one's going to be x and the other is going to be x minus 2. And then we're going to have some degrees because we mentioned there's multiplicities. And these two numbers, degrees, have to add up to a maximum of 5. But we know that because there's a turning point, this has to be even. So you have a choice. It could be 2 or it could be 4. And this one, if this was 2, then this would be 3. And if this was 4, then this would be 1. However, we know it's not a 1 because 1, as we mentioned, has no multiplicity, meaning there is a linear-like feature at the 0, meaning it goes through. So we know that because we have an inflection point, it's going to be a cubic-like feature. So in other words, our function is going to look like the following. X to the power of 2 times x minus 2 to the power of 3 for a total of 5. So this function that we have here comes from only two pieces of information, the two x-intercepts. We need to make sure that this function actually fits another point on the function. So we're going to look for another nice point on this function where we can read clearly where it is. And I'm just going to look at over here, right over here where the arrow is, right over there. And in this case, it's going to be 1 and 2, okay? So let's make sure that this function here fits these 2 points where this point where input is 1 and the output is 2. So let's actually sub an x for 1 into here and make sure that it gets a 2. If that were the case, then this function fits. So let's have a look. So in this case, it would be y is equals to 1 squared, 1 minus 2 to the power of 3. And when we did all the work, all the BEDMAS work, we end up getting negative 1. So it seems like this function does not fit this point here. So we're going to have to adjust for this function. In other words, we're going to have to do the following. We're going to put I'll call it adjustment factor. And we're going to have to solve for a such that it actually fits this specific point on the function. To solve for the a value, or what I call it, the adjustment factor to fit this point here, all we're going to do is sub an x for 2, the input into all the x's for 1, and then the y value, the output, is going to be 2. In other words, we have 2 is equals to y, or y is equals to 2, a bracket, 1 squared, 1 minus 2 to the power of 3, and then we do BEDMAS on the right-hand side, we end up getting negative 1, and then we solve for a is going to be negative 2. In other words, this purple graph here, the equation is going to be y is equals to negative 2 x squared x minus 2 to the power of 3. So this example is very similar to the other one, but if you look at the statement here, it doesn't tell you whether it's a quintic or a cubic or the type of the degree of the function. And this is where you can make assumptions. So based on what we know about the n behaviors here, we know that it's going to be an odd degree. So because it's an odd degree, it could start off as 3, 5, 7, 9. And the question from previous slide is, why can it not be 3? Well, it cannot be 3 because if you look at the multiplicity, this is already minimum of 2, and here we have a cubic-like feature, which is a minimum of 3. So there's absolutely no way that this function could have a maximum degree of 3. So in other words, this could be 2, this could be 4, this could be 6, as long as it's even. And whereas this one here, as long as the inflection-like feature is going to be 3, 5, 7, 9, you can make up whatever you want, hence the word possible equation. So we're going to make it open. We know that the zeros are still the same as before, but however, you're open up to many degrees. So it has to be odd. So let's just say you want the degree not to be 5 because we did that previous example. Let's call it, for example, 9. Okay? In other words, it's pretty much the same thing. I'll just put in the same format as what we had before, but now, right now, we can be flexible on this. We know that this is going to be even and this is going to be odd, greater than 3, not 1. But as long as these two numbers add up to 9. So for example, you can have a 4 or a 5, or you could maybe have a 2 and a 7. There's many possibilities. So again, let's just say you chose to have a x4 and a x minus 2 to the power of 5, then you would do the exact same thing as before. We would choose a nice point. In this case, it'd be 1 and 2, the same thing. We solve for the a value by substituting the input-output for that specific point that we chose, and then you solve for your a value. In this case, is going to be -2. So in other words, a possible equation, when you write this on a quiz or assessment, make sure you actually answer the question by writing the possible equation, in this case, -2, x4, and x minus 2 to the power of 5. So here we have a question where there is no graph given, but the description, the features of the function is given in terms of words. So what do we know about this function? Oh, it's a quartic, so we know that it's an even degree function, and it has 3 zeros. So we can actually start off with this function with the adjustment factor, or some people call it the stretch factor, to fit the other information on the graph aside from the zeros. So it's going to be x minus 1, x plus 2, and x minus 3. What else do we know? The function crosses the y-intercept of -24. What that means is f of 0, when you sub it, keep in mind y-intercept means when x is 0. When the input is 0, the output is -24. Just to sort of bring back the function notation, or x equals to 0, y is equals to -24. So in other words, but however, this is not good enough because this is a cubic. X times x gives you x cubed. This is not a quartic. So there's some information that we need to know. If we look at this part here, it tells you that there's a turning point. So we keep in mind when there's a turning point at one of the zeros, that tells you that this is going to be even. And it's going to be 2. It cannot be 4 because if this was actually 4, then we're going to have a leading degree that's greater than a degree of 4. So we're going to stick with this, and then we're just going to do exactly the same thing as we did before. We're going to substitute our input into x and output into -24. In other words, -24 is equals to a bracket 0 minus 1 squared, 0 plus 2, 0 minus 3. And all we have to do is just adjust, do the bed mass, so 2 times 6, and then we just divide everything by 6, and we end up getting -4. Therefore, your function is going to be -4, in this case, x minus 1 squared, x plus 2, and x minus 3.